For the Caesar cipher, or ROT13, I created this encryption and decryption tool. First thing to know is Caesar cipher is the most basic cipher that is out there, which it's a form of simple substitution cipher. Basically just means we're going to change what each letter is mapped to. It's going to map to a different letter. Or at least some of them will be mapped to a different letter. In this case, all of them will. And we're going to shift it a number of shifts. So we can shift it by 1. And so now A is to Z, B goes to A, C goes to B, D to C, and so on. And so if we keep moving it forward, we go that way. We can also go the negative way, which basically just goes the other way around. Where the ROT13 comes in is when you have shifted it 13 spaces, which is directly half. Now A equals N, B equals O, C equals P, and so forth. You'll notice, though, it's the exact same to decrypt it. So it's literally just taking half of the alphabet and putting it under the first half. Let's take the second half, put it under the first half. So for instance, if I want to say this is a test, I automatically set it to uppercase. You can do it for whatever you want. I'm also not encrypting any special characters. So spaces still persist as we go forward. So for shift 13, that's how that would look. And you can cycle through all of the different shifts. So shift 26 just brings us back to the normal alphabet, which would then, in this case, decrypt it. If I wanted to do a decryption, now I can put whatever my ciphertext is here, and I can go through the different shifts to see which one is the key to my ciphertext. In this case, it happens to be 13, and the plain text is subscribed to one fin dog. That is the essence of it. So if you want to encode, put your text up here. If you want to decode, put your text here. And then you can cycle through the different shifts to give you the key that you're trying to look for. Obviously, this is not the most secure. It only takes, at max, going through 25 different ciphers, or keys for the cipher. So I wouldn't use this for anything that is supposed to be secure. Now to walk through the code. It's pretty simple on the CSS. We have a TD, which is the data of a table. We have the actual table. We have the plain text and the ciphertext input boxes, and actually they're input areas. We have the ID for the shift input, a wrapper, and then the encode and decode buttons, which are actually the radio buttons. So if we look at the HTML, also pretty simple, straightforward. We load up all the information, the CSS, the global files. We then have our header, an introduction. So I kind of explain what's going on, Caesar cipher and the ROT13. And then it's pretty simple. So for the first card, we have our plain text label, text area. On the on change, I have this function. The next card is where we have the shift. We showed the alphabet chart table, and you notice it's empty. We actually populate that with the JS. And then we have our encode and decode button, which are radio buttons. When you have them have the same name, then only one of them can be selected at any time. So that is how you make it so they can't all be selected at the same time. which in this case, obviously, they have to either be encoding or decoding. For the final card, we have our ciphertext. Again, when it changes, we do encode decode function, and then I have my script that has my JSON file in there, or my JavaScript file in there, because I have an onload function separate from the header and footer, and so that's why I put the script here, and we'll show you that in a second. For my JavaScript file, I have my reference at the top from Wikipedia, my decoded alphabet and my encoded alphabet set to blank. Shift is set to 0. I have a regex expression, which we're going to use to do a test later. I'm only looking at characters A through Z in the capital form, and then my encode value, and that's part of the radio buttons. And so we've automatically set it to true. To set my decode alphabet, it's always going to be A through Z. And so because ASCII characters start at 65 for capital letters, then my capital A is 65. And I add I to it, which is first going to be 0, go all the way through 25. Pretty much the same thing happens with the set encode alphabet. However, I want to add the shift to it. And so I call my encode letter function. To display the alphabet chart in the middle, I just have a simple update shift to make sure that that shift has the latest value in it. I set the decode and encode alphabet again. Don't really need to do that, but just to make sure that everything's up to date. I have the top row and bottom row, and then I cycle through the length of the alphabet and just add that index to the top row. Because it's a table, then each one is a table data element. And then I have the top row with the top row brackets and the bottom row with the table row brackets. In order to encode the text that is given, we call this function, which is going to go and grab the latest from plain text, update it to be uppercase. Then I copy it, I grab it again and set it as this text variable. I clear out whatever is in ciphertext, and I cycle through it and encode each letter and add that to the ciphertext. To encode the letter, I send in the character. I immediately get the code of that character, the ASCII code. So for instance, if A was passed in, it'd be 65. I test to make sure that character is between A to Z. And then I do some math on the code of that. So in other words, if it was A, 65, I would subtract 65 off of it. I add back the 26 just to make sure that I can modulo it. I add the shift. Then I actually do the modulo to make sure I get a letter between 0 and 25, or including 0 and 25, so between those. I add back the 65, return that as from char code, so it gives me the ASCII character back. And if it, but then if it doesn't pass that test, then I just return it. So again, any of the special characters. Decode, basically the same thing, but in reverse. So I clear out ciphertext, or I update ciphertext, make sure it's in capital letters, and then set that as the text. Clear out the plain text, and cycle through the ciphertext to add it to the plain text once it's been decoded, and I use decode letter. Same thing happens here. Send in a letter, get the chart code, test to make sure it's A through Z in the capital form, and then I remove the shift. So that time I added it, and this one I subtract it. but everything else is the same, modulo it. If it doesn't meet that test, then I just return the character. Again, we talked about update shift, which is just whenever the shift gets updated, I update it by calling this. As you noticed, I had the encode or decode, and this just, when I, on my plain text and my ciphertext, and also when I shift. So if it's encoding, then it will encode it, and if it's decoding, it'll decode it. So it makes it really have to have one function be referenced in HTML. And then setting encode or decode, it will flip that value for me, and then it will encode or decode whatever is in there. And then I was talking about the onload. So when I load the page, it will determine that by this listener, and then it will update and automatically set my alphabet in the middle to be A through Z on both the up and the top, or on the top and the lower. I have some more ciphers to come, so please like and subscribe to see when those come out. Thanks, everyone.